Hello, hope you guys are doing well. My dog is chewing a bone in the background here. I don't know if you can see her. I don't know. It's kind of muted, but anyway, there is a mini golden doodle chewing a bone. So if you hear some noises, that's what it is. So, all right. I read your journals, and so there are a few things people want me to go over. So I'm going to do piecewise function first. And again, I will timestamp these in the when I post it so you know where you need to go if you don't need everything. Okay, so let's start at piecewise. All right, on piecewise, my advice is to do the easiest piece first. Okay, what I think is easiest. I then kind of work towards the end. I keep track of input and output if I need to, and I make sure to write a note to myself that, hey, this is a whole, okay? So what I would do is start here. Now, notice this is different than the ones I did in my other videos. This is not a point. It is infinite many points because it's saying, hey, between 0 and 2, the output is 2 no matter what. So if your input is 0, so if you make an input-output chart, if that helps you, when the input is 0, that's going to be what, a whole. So I'm going to write a note there. That's a whole. So this is a whole, but the output is 2, but it is a whole there. So it's not really there. But notice 1 would be in here. So when my input is 1, notice my output is still 2. 1.5 could be in there. 1.5. But again, see how the output is just 2. And 2 is not a whole, but its output is 2. So there, if I'm at 0, it's saying the output is 2, but it is a whole, all right? If I'm at a half, that's in there, the output is 2. And here, and then there's infinite many points all the way. So it's a constant line until I hit 2. Now 2's included, but that's a solid dot. But all of these are here. This is kind of like my example with mailing a package when we did the step function. Or if you wrestle, like say you weigh between, and I know nothing about wrestling. I watch David Carr wrestle, and that's about it, right? Like on TV, I'll watch him, and then I'm done. But there's weight classes, right? So say someone can weigh 158 pounds, but they give them like a 1 pound leeway. So if you weigh 157 all the way up to 159, or even half pounds in between there, you get to wrestle at this weight. It's not, you know what I mean? There's like a little leeway there, okay? Another example would be salary, right? I am a salary person, right? So with my job, my salary is like that, right? Like if I work more hours this week because I have all those quizzes to grade or I have tests to grade, it doesn't matter. Like some weeks I work 40 hours, some weeks I work 60 hours. My paycheck is constant because I'm salary. It doesn't matter. Okay. So that's what this is. It's not a single point. It's a bunch of points, right? Infinite points that all have an output of 2. Okay. Where the other ones I did was like, hey, when the input's 3, the output's 2, it's 1 point. This is not the scenario here. All right. So check. That's done. Usually I like to do positives next, but this is a prettier function than this, so I'm going to go over here. Now, you should know that this is the parent function of a parabola that goes through 0, 0, 1, 1, 2, 4, 3, 9, because you can square negative 1, 1, and so forth. But notice I only want the values, the inputs that are negative. Now, you might want to make an input-output chart if this helps your brain. When the input is 0. Now, I know it says it can't equal 0, but remember, you want to put it in there because you want to indicate that with a whole. Because otherwise, you're going to be putting 0.1 in and 0.111 and 0.009, and you don't want to do that. Okay, so I'm still going to sub in an input because remember, over here, these are your inputs. These are your outputs, right? Functions have inputs, function have outputs. All right, so if I sub in 0, obviously I get 0. Now, I can only have negative values. So a negative 1 squared is 1, negative 2 is 4, negative 3 is 9, which should not surprise you because you're on this side. None of these count because remember, that's over here. All right. So when I sub in 0, I get 0 squared, but it is a whole, okay? So I'm going to sub that in, and at 0, 0, I get a whole. Okay. What happens at a negative 1? Well, at a negative 1 times 1, or a negative 1 times a negative 1 is a positive 1. Negative 2 is 4. 1, 2, 3, 4. And 3 would be 9. So that's what? 4, 5, 6, 7, 8, 9. All right. And again, you know it's a parabola, but you know it's just this half. Now again, make it kind of curvy, right? We don't want to make it, you know, look like an absolute value function. And it does go off to infinity, right? Because, right, this goes off forever, correct? So this part of it goes off to infinity, okay? All right, so, you know, and again, there's infinite many points on this line, right? Infinite many, that's what the line means. Okay, so now I have to go to the positive side. Okay, now again, let me think about what I know, and then we'll make an input-output chart to help me. All right, transformations. Whatever the opposite of this is the shift on your x. So I know that's going to go over 2. Whatever is on the outside is your shift on the y. So it's going to go over 2 up 4. This is a quadratic, so I know it's going to be a parabola shape, similar to this, right? This is the parent function, parabola, but it is negative, so it's been reflected. So I know, in a sense, right, that's going to look like that. Okay, now, what do I want? I only want the values that are greater than 2. Okay, so notice I'm not going to want any of those, okay? But again, help yourself out and make an input-output chart. So this is your input. So you're going to put 2. You're just going to write yourself a note that it is a whole. And then you want the values that are bigger than 2. So 3, 4, 5, and again, this goes off to infinity. But you know it's a parabola, so you just need to get the shape of it, all right? So when you sub in 2, let's sub that in, okay? You get 2 is 0, 0 squared is 0, negative doesn't matter, that's 4. Now, that should make sense to you because you get 2, 4 is the vertex. That is the maximum value here. So if I go over 2, 1, 2, 3, 4, remember I wrote myself a note, that's a whole. All right, let's sub 3 in. Now we know it's going to go down, right? Okay, so, you know, we just need a few more points to get kind of the shape of this. Let's sub 3 in. Sub 3 in. 1 squared, you get a negative 1 plus 4, so that looks like it's at 3. Did I square that? Let me double check. 1 squared is 1. Yep. Okay, let's sub 4 in. 4 is 2 squared is 4. That'd be a negative 4 plus 4 is 0. Let's sub 5 in. 5 minus 2 is 3. 3 squared is 9. And a negative 9 plus 4 is a negative 5. All right, so we have our whole. So at 3, 3, 1, 2, 3, 1, 2, 3. We have a point at 4, 1, 2, 3, 4. We have a point, and then at 5, negative. Okay, so, all right, here we have our beautiful, beautiful, beautiful shape, okay? All right, so this is our piecewise function. Notice it passes, do I have a point somewhere there? Maybe not. I do here, right? But I don't at 2. Where does it, at 0, I mean, I'm sorry. At 0, we don't have a value there. We don't have a value there. No, we have a hole there. All right. So we just have a hole on top of a hole there, which is fine. All right. Okay. I'm going to do a couple more in this video, but hopefully that helps with a piecewise. I know some of you are still struggling. Okay. Say I want to create a function. Okay. So remember, there's always going to be 2 things, something from your brain, maybe something given, maybe 2 things from your brain, maybe 2 things given, something along that line. Okay. So say that I am given a problem. Okay, now again, some of you were asking about transformations. I know that this has been shifted 0 on the x because there's no shift on the x and up 25. So I know I'm up here. The negative tells me that this is reflected. So I know it's a parabola that's been reflected. Okay, so I know that much and I know the function is right there. Okay, now I can't figure out my x-intercepts. If you sub in, 5, you get 5 squared, you get 0, and a negative 5 squared, you get negative 25. So I know this goes to 5 and a negative 5 if I care. All right, now I might say that you want to draw a rectangle inside here and find the area of that, or maybe a triangle. So let's do a triangle. So I might say that you want your triangle to have a point on the origin. You want it to, you know, touch the x-axis. And then somewhere you want it to go up on to that function and you want to touch it, okay? And you want to find the area of that triangle. Now, the thing is I don't know, that triangle could be lots of places, right? Like it could be a really tall, skinny one, right? But that doesn't look like it has much area. Or you might be like, well, maybe it's more fat, right? And kind of more squished. I don't know. But all I'm going to do is I'm going to guess that I'm going to go over and up, and it looks like this. Okay. So what are my two formulas? Well, I'm giving you this one. The other one you need to know is area of a triangle is half base times height. So instead of using base and height, though, we're going to use x and y because we're in trig and pre-calc or whatever, and we like to use x's and y's. So like, here's my x, here's my y. I'm going to use that instead of base and height. So area is that. Okay. So remember, to create a function, you cross a line. So you have to combine these. So you're going to keep the formula, you're going to sub this into it to create a function. Okay, so I know the formula is area is half, and we're going to use x times y. You want to get rid of the y so that you have one variable, which is x. Then you have a function of x. So you got to get rid of the y. How do you get rid of the y? Well, f of x equals that is the same as saying the output or y equals that. So I'm going to sub this in where this used to be. Okay, because in a sense, with substitution in math, it's kind of like you have two quarterbacks of equal ability. Okay, and if one quarterback gets injured, you should be able to put the other quarterback in and have the game go on. Or if it's volleyball, you have a setter. The setter needs to sit out for a little bit. You're going to put another setter in, and hopefully, they would have the same skill set. They'd be identical. You can still win the game. So math, these are identical values, right? They're equal. So what I'm going to do is I'm going to cross the line, and I'm going to go from a formula to becoming a function. So what's my y value? Negative x squared plus 25. Okay. And you're done. There it is. That formula right there, or that function, we switch from a formula to a function. Now, this graph is of the, kind of the two separate things. This is them mushed together to get area. So if you graph this, you're going to look for the maximum value, and that's going to give you the maximum area. So notice your input is x. That is your base. Your output is a of x. That is not your height. That is your area. All right, so let me pause for a second. I'm going to pull up Desmos so we can look at this. Okay, so here's Desmos. And so this is just the original function. But now, or the original parabola, I'm sorry. I'm going to go ahead and change this to the area function, which is, that's your y. And remember, triangles are half base times height because they're half of a rectangle, half of a parallelogram. So I have half, then x, and you can use a fraction either way. And I'm going to change the name of this to area, a of x for that. Okay, so here's my new function. Now, notice the domain, the only thing that makes sense is to have positive area here. So, and remember how I said 0 to 5? Well, if I land at 5, I get an area of 0? Because it wouldn't even be a triangle. It'd be flat. It wouldn't fit. So I would say domain on this is 0 not included to 5 as far as that goes. But let's go here. Right there, that's the answer you want. Okay. So the width would be 2.887. So I'm going to write that down on my notes. 2.887. And the area, not the height, the area would be, about 24 square feet, square inches. All right. Let me go back. I'm going to pause and go back to my .cam. All right. So let's go back. So we know that this is 2.887. So if I sub that back in there, I would have to take my 24 divided by a half and divided by that to go backwards. So I'm going to take my 24.056. I'm going to divide it by that, 2.887, enter. And then I'm going to divide that by 0.5. All right, so it looks like, and we'll double check my answer here. Is this right? 16.665. Hopefully I did that right. Okay, so if I have that times 2.887 and I divide by 2, yeah, I get the area. So I know that at x, at an input of 2.886, so that's the width, I know that it's going to spit out that area. That is the biggest triangle that can fit inside this parabola.